How's it going? I'm meteorologist Bill Martin. I am a meteorologist. That's why I said I'm meteorologist Bill Martin. I've been in the Bay Area for a long time doing weather. Undergraduate was Cal, Berkeley, climatology, meteorology, physical geography, and then atmospheric science at San Francisco State, and then a bunch of years in television and doing other assorted things. So I know a lot about weather. I know a lot about California history. I know a lot about California. I am a fifth generation California. My family goes back six generations, both sides in California. So I'm pretty passionate about this place. And one of the things I'm noticing more and more lately is the idea that we have things that have impacted this state, that are impacting the state, and that will impact physical things, natural things to some extent. And so those three things are earthquakes, fires, and droughts. And that you go all the way back to the missions and well beyond that, earthquakes, fires, and droughts. Present, earthquakes, fires, and droughts, and future. It's just how it's going to be. So I thought I'd talk a little bit about earthquakes today. We haven't had anything a lot. We haven't had a lot. We've had, we go, sometimes we have an earthquake almost every day, little ones that you don't notice. So if you're up at the geysers or up at the triple point, the triple juncture, which we'll talk about more. I think that we are due, and I think everybody thinks we're due for something bigger. And that would come probably on the San Andreas Fault, which does connect to the Mendocino Triple Point. So the quakes themselves, if they don't happen, the strain builds up, and then when they happen, there's a lot of tension that is built, a lot of pressure, and the reason this pressure builds up is because the faults or the plates, as they bump together and rub, they move about the North American or the Pacific plate moves a couple inches a year, about the speed your thumbnail grows. So it moves, and so over a couple inches a year, in 10 years, you're at 20 inches. You're 2 feet. That whole plate has moved 20 feet. And so a lot of times you don't get an earthquake. We haven't had a good earthquake in 20 years. So that strain has built up. So when it finally pops, right, you're going to get a lot of activity. And we're due. And the San Andreas Fault's the one we talk about. And there's a bunch of little faults that run all over the place. And one of the things that I think is it makes it easier to understand faults is if you think about a puzzle that you've put together, and you let's stick this hand on it. You stick your hand on it, and you turn. You turn like 3 inches, 2 inches, and all the pieces you turn kind of get a little rumply, but it's those pieces on the edges, right, that move. They fracture. They spread apart. They get together. Those are faults. So all those little junctures. So that's why I've been mapping California faults, mapping faults in general, almost impossible because it's everywhere. The main faults we know, like the Hayward Fault, the Calaveras Fault, and faults like that. So today we're talking about earthquakes. This is Ferndale, and this is a big quake, the last big one at that triple juncture where the three plates meet, Juan de Fuca, North American plate, and the Pacific plate. So it looks like they're having some kind of a, gold nugget days kind of a thing going on up there. But in the process here, they have this quake that is a pretty good sized quake, and it's out at the triple point. It was a big enough quake that it actually lifted the land at the coastal sections up 4 feet. So the whole North American plate got bumped up 4 feet. Yeah, so the potential there for a tsunami is huge. The potential for this is huge. They had 3 quakes too. They had this Ferndale deal. They had the first quake was 7.2, which is big. And the second quake was 6.5, which is big. And the next quake, the third quake, was 6.6. So it's fascinating. In this area too, the fastest growing mountain range, the King Range, which is just to the west, in the east, that range is growing faster subsequently than as fast as the fastest growing mountain ranges in the world, like the Himalayas. It's growing really fast. And the fact that it popped up 4 feet or got 4 feet of increase during this event. So earthquakes are going to be part of it. This was the 89 quake. I was working this day, and I'd say fortunate. I was fortunate enough to be downtown San Francisco. I was working at Cron 4 as a our weekday weather producer for Mark Thompson. He was at the World Series. Fortunately, there was a lot of people at the World Series. This is dramatic stuff, huh? A lot of people at the World Series, and so there weren't that many people on the roads, fortunately. But this is what the Bay Area felt. This was about 5 o'clock, and it was an unusual. I mean, the first time the A's and the Giants had both been in a World Series, and so the Bay Area was quiet. It's as quiet as the Bay Area gets. But I remember being at the TV station and having people running in, freaking out, talking about the Bay Bridge falling down. I could see parts of the bridge. I could see people who were on the bridge. They abandoned their cars and ran back to the TV station, which was maybe a couple miles at that point. And it was just sort of a really interesting thing to experience. And I was fortunate because I actually saw the buildings going like this, the high rise. Because if you think about where I was, the parking lot at Cron, which I don't even know if Cron's still there, but I could see the tall buildings. And the longer this thing went on, the buildings were doing this back and forth. But then right towards the end, they started, especially the wood ones, they started to whip. It was weird. And it stopped right then. But I could see if it had gone on for another 30 seconds. I think it was under a half minute, this quake. But, a good quake can go on for 2 minutes. But the building started to whip. And that was interesting to me. So I saw that. So this is what it looks like in terms of earthquakes over the last 40 years. And you can see in the United States, obviously everything's going to be on the West Coast, on the Ring of Fire. There's the San Andreas Fault right there. The part of this fault is moving, right, or the Pacific Plate is moving this way at about 2 inches a year. And this plate's moving this way. So the separation, the movement between the places is about 2 inches a year, which is creating about 2 inches a year of stress. These are all the earthquakes. This is 83. This is through each year. So you realize that we are a hotbed for earthquakes. The big circles representing very, very large quakes. And one thing I'd like you to notice, if you can, I'll see if I can pull in a little closer here. But in this zone here, this is the triple juncture where they're piling up right in there. And that's my area of biggest concern is that, because that's on the south end of the Cascadian Subduction Plate, which is a megathrust fault, which is basically why we have the Mount Lassen and Mount Shasta all the way up into Rainier and Baker. It's a subduction zone. And the potential for big quakes exists on that zone. The last big one was a couple hundred years ago, last real big one. But they're due. They're due. And they figure there's a big one every couple hundred years. And that's the one that'll produce a 9.0. That's the one that will produce significant tsunami potential. And that's the one that could cause problems for big problems for California, obviously. But I think in terms of water, in terms of the potential for the tsunami event. So here's the Ring of Fire. And this is California right here. There's the triple point right here. This is the Juan de Fuca Plate, which is the subduction zone, which is going this way. Pacific Plate's going this way. North American Plate's going kind of this way. And they all merge into each other. It's a convergence zone. And if you notice, subduction, again, represents land that is sinking and getting hot. So it's being pushed under the North American Plate. And it heats up and it bubbles up as Mount Lassen, as Mount Shasta, as Mount McLaughlin, as Mount Bachelor, as the Sisters in Oregon, Rainier, Baker, all those. And you can see all the way through Alaska, all the way across the Pacific, all the way just North Australia, South America. So it's a very hot and active zone, and that's where most of your earthquakes are in this, what we call the Ring of Fire. And we're right there, and we're in probably one of the most high-risk parts of the Ring of Fire based on population and proximity to ocean. This is this is today. This is the number of quakes. This is, the blue ones are today, the two, and then the yellows are the past week. So all in all, in the last 7 days, you've had 7 earthquakes. Not giant, but it just shows you that's the triple point. That's where the 3 plates meet, and they're just bubbling. They're converging. They're clashing, and they're moving. They're constantly moving, and that's something you can't stop. And that's why I can say with complete confidence that we're going to have ourselves another big earthquake, and we're not that far off. We really aren't. And so, I guess being prepared. I mean, I'm not going to go into the whole get a bunch of batteries, store water and stuff, but I think the biggest thing is be aware that it's gonna happen. And lots of things have changed. There's been lots of infrastructure grades in the marina, for instance, in San Francisco, in private homes. After 89, people went to town on the shear wall, right? People went to town on, sturdying up buildings that were in sediment, which is, or low-lying areas, river basins along the bay, where the things people have really gone to the great effort of putting hard pilings into hard rock in San Francisco. All those new buildings are into rock. So it'll shake, but it should not liquefy. So I think it's a very different story than 89. I saw the freeways come down. I saw the Cypress structure. I saw the Bay Bridge, partially become compromised. But things have gotten better. So if you're an out-of-towner and you're worried about this, be worried. But I have to tell you, I've been in every earthquake since 1958. I don't remember this because I was teeny, but I've been in a lot. And they're pretty awesome, especially if you're just calm down and go, okay, here we go. Because you got a P wave that's really loud at first, and then you get this S wave that comes through that starts the shaking, and they can last a minute to 2 minutes. I remember in San Francisco when the buildings were moving, when I was watching them, I remember them when the earthquake ended, they kept going. Because there's an entropy, right? They were going. They kept moving, and they would not slow down. And they finally did, but it felt like it took 2 minutes for the buildings to stop swaying. I know. And then the other thing, I was on Van Ness, that was a bunch of car dealers back in the day, and car alarms had just come out. And the thing I remember most was the car alarms was everybody's car. All the new cars had car alarms. So it was just these noises I'd never heard because they were brand new. Car alarms were brand new. So it was like nonstop. It used to be they'd honk the horn. I think it still does do that, doesn't it? And then the other thing I remember is people coming out of the buildings, kind of shocked and dazed. And you see that in some of the video I showed you, and some more I'll show you. That there's this sort of it's a shock you go into, even when it wasn't that big. 89 was big, but it wasn't that big. I didn't think so. I mean, we shook pretty good. My car bounced and stuff, but yeah. So anyway, just here it comes, right? So here's the triple point. Triple Junction is called. That's where most earthquakes occur, and the subduction zone is from about Cape Mendocino, or as I said before, Mount Lhasa northward. That's subduction zone. But subduction zone is where we could see the biggest quake because of this. The Pacific plate dives under the North American plate, and what happens is it dives and it pushes the North American plate, which is denser and harder, pushes it back and just loads it up, like pushing on a spring, just and then it pops. Land goes up, water goes up, tsunami, big earthquake. So this area right here, potentially the most, to me, the most scary part of earthquakes in California. The other reason is because the amount of time from an earthquake to a wave hitting Bolinas or hitting Half Moon Bay, hour and 5 minutes. That's not a lot of time. It sounds like a lot of time, but by the time we figure out there's an earthquake up there, because we may not even feel it, probably you'll feel it, but may not. But if there's a 9.0 up there, you'd feel it. But it would take about an hour to get here. They move about 500 miles an hour. And in this zone, up in Northern California, Crescent City, Del Norte, Humboldt, up to Brookings and Coos Bay, 5 minutes, 8 minutes, not very long. So it definitely takes some pre-preparedness, I guess you would say. Here is the sinking. This is just reiterating the seafloor dives. It gets hot down here. The mantle is hot. And this heated magma melts and comes up as volcanoes. That's how the volcanoes are formed. That's why they call it the Cascadia Subduction Zone. So it does a lot of things. It creates volcanoes. It creates in here, see this area here? That's that area that's going to get drawn back because this is constantly pulling it, and this just gets wound up tighter and tighter and tighter, and then boom, boom, it pops. And when it pops, that's when you get your big earthquake, potentially upwards of a 9, and that's when you get the big seafloor or ocean dispersal, or what's the right word for that? Displacement. So this is an interesting map. This is the Cascadia quake. This is on the subduction zone. This was reconstructed around 1700, and this shows the wave that comes off of it. and how it propagates. So this is 4 hours in. It's all the way to Mexico in 4 hours. It's all the way to Hawaii in 6 hours. It's all the way to Japan in 7 hours. And it's big. And it just rumbles. And in Japan, which tsunami means harbor wave. That's what it essentially means. In Japan, they called it a ghost wave because they didn't feel an earthquake. They're used to having, because they have their own subduction zones. They didn't realize it came from over here. Of course, 1700 was a long time ago. But pretty good sized tsunami. And if you look at these dark reds, that's representing 30 plus feet of ocean water coming in. That's a lot. That's a whole lot. So that's the potential. And again, that's a 9 point, I believe it was, what was that one? That was a 9, I think it was a 9.2. And that is incredibly possible to see in this area, especially coming out of this zone here. So most of the potential earthquakes on the San Andreas are going to be less aggressive. They're big and they can be long and last, but typically it's that subduction and that spring loading. You'll get that in a transcurrent fault, which is the San Andreas, but you're going to see it's not quite as abrupt, right? The strains are building up. They probably have more of an opportunity, I would imagine, to release a little bit of stress and tension as each movement occurs. Whereas that subduction, you're just loading it. And now, not to say you're not building up stress and strain on the San Andreas fault, but I think the subduction zone has the potential to produce a much bigger quake. So, and I think that's correct. So 120 years of earthquakes and tsunamis. I love this map. This shows, first of all, the size of the circle is how big the darn earthquake is. It's not going to give you numbers. This is 1902, and we're going all the way through the last 100 years or so. And that purple, that's a tsunami. So about every couple years, you're getting a big earthquake on the Ring of Fire, right? That's those areas. You're getting a big earthquake. It'd be another tsunami. This one's the one that kind of freaks me out here. You'll see it. So I'll stop it when it happens. Boom, that. So what do you got? What happened there, right? That's big tsunami up in the Gulf of Alaska, or actually up towards, all the way up into the Aleutians. And then this earthquake down here, and it's like 2 tsunamis. I mean, can you imagine what that must have been like? That was 1923. And it doesn't look like, it looks like it missed a lot of the west coast of California, but I mean, I can't even imagine what was going on in that world. So again, these earthquakes are nonstop over 120 years, and then go a few more years, you wait, and then you'll see a big dot, and then you'll see the tsunami. And I think you'll see the San Francisco, or there's a big one, and you see the fingers reaching out, indicating a wave of over 20 feet, maybe 30 feet, the big dark purples. And then you can see the triple point here, lighting up occasionally. And then this is Alaska, and that's 48. And then I'll show you, I'll stop in Alaska 64, because I was actually up there for that tsunami. So you get an idea, these aren't rare events. I mean, they used to seem rare to me, I guess because I wasn't really completely savvy to what was going on here and looking at a chart like this. But this is not rare. It's not rare to see a tsunami. It's 120 years. It's in our lifetime it's rare, but in geologic time it's nothing. This is the Alaskan quake. Well, let me go backwards. I think the Alaskan quake is 64. Let's see if I can hit it up. I just want to stop there because I was actually in Fort Bragg when this happened. And we spent the night in a campground. So I've been in a lot of big earthquakes. I wasn't in, the Alaskan quake lasted over a minute. In the tsunami, we were in the tsunami zone. And I remember loud noise at night. I think we were camping. And it was sounded like rushing water, but it's hard. I was only like 6 or 7 years old. But when we went to the beach the next day, I have pictures somewhere around here. The beach was just, of course, nobody at the beach. Listen, this is before the internet. This is before cell phones. So nobody knew anything. We didn't know anything, and we didn't expect to know anything. And even the car radio wasn't really working because, well, first of all, Dad wouldn't listen to the radio, which always pissed me off. I'm like, why can't we just listen to some music, man? We had to talk. So, it's awesome. But we didn't really know. So we went down to the water's edge. And the thing I remember that was most stunning was the amount of debris, tree trunks, trees, just everything was kind of stacked way up on the bluffs. There was just driftwood and you can imagine this slosh of water going through. Crescent City had a certain amount of people lives lost, damages done to infrastructure, and I didn't. I think I mentioned this. I don't know if I did, but the petroleum quake, that Ferndale petroleum period in '92, they had three pretty good sized quakes within a few minutes of each other, and so it was sort of like a multiple event. So just wanted you to see that map because it makes you very aware. It makes you realize, oh, okay, this is 1964. So this is the Alaskan quake, and this is going to show the movement of a tsunami and how quickly it would or did get to San Francisco. It went into Tiburon and unmoored a bunch of boats. Didn't have a good angle on the place, but I'm going to click it right there, and you're at 4 hours. So not a lot of lead time in six. Like I said, people, I'm sure there was people didn't know there was a tsunami coming. And then you can see it kind of linger and moving across the ocean. And then you see the refraction and the reflection of the waves. So yeah, I mean that triple point has me a little bit worried. I remember this shot well. This is the Bay Bridge, and I could see how that would happen. And people were kind of fleeing. People that were out that told me they were out on the bridge that day were kind of running, and there's a lot of general panic because I can imagine I wasn't on the bridge, but I can imagine the bridge was swaying quite a bit. So what did I just say? Fires, earthquakes, drought. We're talking about earthquakes today. That's kind of what it's all about. If we get a big one, it's going to come from that triple point. If we get, we'll still see some good-sized quakes from the east, from the Cascadia, or from the San Andreas, certainly, because it's partially that is the San Andreas fault. But just be prepared for it, and don't. I was in two. My dad and both my grandpas were in the big quake, and the stories. If you don't panic, you're going to be fine generally. Not these pictures are showing doom and gloom, which was horrible. The Cypress structure was horrible. That's right by Channel 2 where I did work recently. So anyway, yeah. Subduction zone, Cascadia Subduction Zone, mega thrust fault has the highest potential for a giant earthquake, and it's due. I know. Okay, I'll see you back here.